When you enter in chemistry world, have you ever asked from anybody, from yourself, how those chemical reactions formulas just came from? Although it's easy to understand the chemistry formulas from any classroom books or any kind of books, but it's hard to imagine what's going on inside the atoms. And what's interesting about this topic is that these chemical reaction formulas was invented about 19 years, 1910, 1940. Sorry about, but what I'm quite sure about is that it was invented before the atom structure was just postulated and then confirmed in the world. In this video, I'm going to explain about how beginning of the chemistry came from kind of physics related stuff. You need to have a little bit of background about math and physics. Here are the simple chemical reactions. I hope you have just played around with these kind of chemical rules even without understanding what's going on inside the chemistry or atoms. But today we're going to understand how people just found these kind of rules in 19th century when there was no any electricity, internet, and there was only math. And today we're going to use only math and physics formulas to find out chemical atoms structure. So let's go to our lab and do our experiment. Before we go to our lab, let's find out what we're going to do. We're going to use rules that physics scientists made, which is ideal gas law. Specifically, I'm going to use K-Lewis formula, which is volume is constant. And here the diagram of the box, similar equivalent of the two gas volumes will be inserted, and then the reaction pressure will be observed. Again, volume is constant, temperature is going to be constant as well. We're going to wait till the temperature will be equivalent to the room temperature. After then, we're going to measure the pressure, and these pressure ratios is going to show the molecular concentration ratios differences, and that's what's going to show how the atoms are behaving when they are reacting with each other. And that's how they found as well. That's the main part of the physics and chemistry. Let's look at our lab. We have tubes to bring the gas into the box of barometers to measure their pressure. And let's open the box. The volume is equivalent right now. It can be changed, and also we have the hole opener as well to mix the gas to begin the reaction. And we have our main atoms, hydrogen, dichloride, nitrogen, and oxygen. We're going to bring them and then insert into volume. And right now what I have to do, just to look at the pressure and observe the differences between them. Well, we're back to our desk again, but along with all data. So here the first reaction, hydrogen plus chlorine, and product is hydrochlorine. Well, what's the difference between these reaction pressures? 1/2. What does it mean? Meaning that after the reaction, the molecular concentration was increased. That means that 1 plus 1 equal to 4. That's quite interesting, right? Okay. Let's look at the second reaction. Hydrogen plus oxygen. The pressure ratio was 1/0.0.775, which is strange number, but this means pressure was decreased after the reaction. It kinda means molecular count was decreased. Well, that's good, but interestingly, when there was volume ratio difference, volume ratio was 2/1 between hydrogen and oxygen. The pressure difference was exact numbers, 3/2. It's perfect. This is going to illustrate how the atom structure is going to behave between each other. Okay, let's look at the third one, hydrogen plus nitrogen. And again, for the first time, when volumes was equal, the pressure difference was 0/7.6, which is not an ideal number. Okay, but when the hydrogen and nitrogen volume difference was 3/1, pressure difference was concrete number 2/1, meaning that pressure was decreased after the reaction. Oh, that's cool. That means that number of molecules was decreased. That's going to show structure of the atom. Yet strange data, but we're from the future. That's right. And the process was something like this. They just keep exploring these pressure differences as well as all the data. Although this wasn't just a one proof of concept that how the atoms behave with their specific rules, which is now known as a valency, but there was different inventions, like there was crucial one such as Avogadro, Boltzmann's constant, and etc. But this one was one of the most crucial experiments that showed us how molecules just reacting with each other, and they have some kind of rules which is known as a valency. So that's all about it for today's video. and that's how they found the valency. And this is exactly what how the chemistry just started in those days. And I hope these kind of simple stuffs will be much more crucial as well in our life. And then we hope that we could also bring new life for our next generation, like they did with these simple formulas. Yeah, I hope you find something new today. Hope you enjoyed. Have a good day.